So you've heard about 3D printing. It sounds like something from a sci-fi movie, right? A machine that just makes stuff out of thin air. Well, not thin air, but pretty close to magic. A 3D printer is basically a robot that builds things layer by layer. Imagine building a Lego castle. Now imagine a tiny nozzle laying melted plastic, one super thin layer at a time. It's like a very precise hot glue gun controlled by a computer. You give it a digital blueprint, and it brings the design to life. It's amazing, and sometimes frustrating. The best part is these machines let you create things that exist only in your head. Have you ever needed a tiny bracket you couldn't find anywhere? Or wanted a phone stand that was just right? With a 3D printer, you can just make it. You become the factory. You can design it yourself, or download a million free designs online. It's a gateway to inventing, tinkering, and solving weirdly specific problems. And trust me, I have a lot of weirdly specific problems that need solving. This isn't just for super geniuses in sterile labs. It's for us, the curious. For people who take things apart and maybe put them back together a little differently. Think of it as your personal creation station. It's a tool that turns ideas into tangible objects. All right, let's demystify this plastic-spitting robot. How does it go from a file on your computer to a physical object in your hand? It's a process called additive manufacturing. That means building things by adding material. It's the opposite of sculpting from a block of marble. Here, we are building up. Most beginner printers melt a plastic string, called filament, and draw with it, one layer at a time. Each new layer squishes onto the one below it. The layers fuse together. Slowly, the object starts to take shape. The process usually starts with a 3D model. That model is a digital file, an STL file. You can design one yourself in Tinkercad, or download designs from Thingiverse. Take your model, say a little boat, and prepare it with a slicer. The slicer slices your model into hundreds or thousands of thin layers. Think of slicing a loaf of bread. After slicing, the software outputs G-code. G-code is the robot's script. It tells the printer where to move the nozzle. It tells the printer how fast to go. It tells the printer how much plastic to push out. It tells the printer what temperature to be. Load that file via an SD card. Make sure a spool of filament is loaded, like thread on a sewing machine. Press print, then the magic starts. The printer heats its nozzle. It melts the tip of the filament. It traces the first layer of your boat onto the build plate. When that layer is done, the build plate moves down a tiny bit. When you start shopping, you'll see two main types of 3D printers that are popular for home use. FDM resin. Don't let the acronyms scare you. They're actually pretty simple. FDM stands for Fused Deposition Modeling. This is the one we've been talking about, the one that melts a spool of plastic filament and draws with it. Think of it as the workhorse of 3D printing. It's fantastic for beginners because the material is cheap, it's relatively easy to use, and it's great for making functional parts, prototypes, toys, all sorts of fun gadgets. My kind of machine. The plastic filament they use, usually PLA-PTG, is non-toxic and comes in every color imaginable. The downside is that you can sometimes see the layer lines on the finished object, so the surface isn't perfectly smooth. But for most of my projects, where function beats fashion, that's totally fine. Then there's the other kind. Resin printers. These are also called SLA, stereolithography printers. Instead of melting plastic, these machines use a pool of liquid photopolymer resin and a UV light source. The printer projects an image of each layer onto the bottom of the resin tank, which cures or hardens a thin layer of resin. The build platform then lifts up, pulling the hardened layer with it, and the process repeats. This method allows for incredibly high detail. The finished objects are perfectly smooth and can capture tiny, intricate features that FDM printers just can't manage. So why doesn't everyone use a resin printer? Well, there are some trade-offs. The liquid resin itself can be messy, smelly, toxic, so you need to wear gloves and have good ventilation. The prints also need to be washed in alcohol, then cured under a UV lamp after they're finished, which adds extra steps to the process. The finished parts are often more brittle than FDM prints. Okay, you've decided FDM is the way to go. Awesome. Now you look online and see 100 different models. Your brain starts to melt. Don't panic. Choosing your first printer is all about balancing a few key things. Your budget, how much you want to tinker the size of things you want to print. First, let's talk money. You can get a good entry-level printer for around $200 to $300. These are often kits you assemble yourself. That can be a fun learning experience. Or spend $400 to $800 for a mostly pre-assembled, user-friendly machine. These printers often include things like auto bed leveling, which is a lifesaver. Bed leveling means making the print surface flat and the right distance from the nozzle. Doing it manually can be a huge pain and a common source of failed prints. A printer that does it for you will save you headaches. Another thing to consider is the community and support for the printer you choose. Creality, Prusa, Bamboo Lab. When, not if, you run into a problem, someone's probably already solved it and made a YouTube video. Tutorials, troubleshooting guides, available upgrades. Don't buy an obscure printer with no community just because it's a little cheaper. Finally, think about what you want to make. Most beginner printers have a build volume of around 220 by 220 by 250 millimeters. That's big enough for gadgets, toys, household fixes. You probably don't need a giant printer to start. You can always print larger objects in smaller pieces and glue them together. Focus on finding a reliable, well-supported printer that fits your budget and has helpful features like auto bed leveling. The goal is to spend more time printing and less time pulling your hair out. You got your printer. It's assembled, it's plugged in, and it's staring at you. Now what? Your very first print should be something small and simple. Most printers come with a preloaded test file on the SD card, a small cat, a dog, or a little boat called a Benchy. Print that first. It's designed to test your printer's capabilities. It will give you a quick win. The feeling of watching your first successful print finish is pure joy. It's like your new robot pet just did its first trick. You'll want to show everyone. Before you hit print, let's talk safety. We're dealing with very hot parts and moving machinery. The nozzle gets hot enough to melt plastic, enough to give you a nasty burn. Keep your hands away while it's running. Even though PLA is non-toxic, melting plastic can release ultrafine particles. Use your printer in a well-ventilated room. Don't put it in a tiny windowless closet where you also sleep. Common sense. Easy to forget when you're excited. One of the most common reasons for a failed first print is bad bed adhesion. That's when the first layer doesn't stick to the build plate. The whole print can turn into a mess of plastic spaghetti. Hilarious once, annoying after many tries. To avoid this, make sure the build plate is super clean. Wipe it with isopropyl alcohol on a paper towel. Also, make sure your bed is level. No auto leveling? Watch a manual leveling tutorial. It's the single most important skill for successful printing. Finally, embrace failure. Your prints will fail. It's a guarantee. You'll come back to a beautiful plate of plastic noodles. Prints will warp or fall over. Don't get discouraged. Every failure is a learning opportunity. This is how you get good at 3D printing. Now go make something.